Hi everyone and welcome back to another video. It's the Somewhat Tutor, and today we're going to be looking at resolving forces in trusses. So in this question what we've got is we've got a rigid jointed truss A, B, C, D, and it's simply supported at point A and a pin joint at point D. We've got a point force acting on point B. So what do we need to do to find the reaction forces at point A and D? And that's what we'll be discussing in this video. So again, like always, I start by looking at my joints, and that's my two joints, which is a pin joint at A and a roller joint at point D. So we've got one vertical force at point A from the pin joint. We've also got a horizontal. As it's a pin joint, it can't move horizontally or upwards. So that's up and down and side to side. It can't move. It's pinned to that position. However, with a roller joint, it can move left and right. So therefore, it has a vertical force of V only, as it's rigidly connected. Likewise, I've got my key of going positive up and to the right, and likewise with any moments, positive clockwise. So let's start by drawing our free body diagram. And remember, that's always the key step to expose all our forces acting upon our diagram. So we've got two supports, one at point A, and let's just label this up. So we've got a vertical force at point A, which is VA. We've got a horizontal force HA. We've got a unit load of point Q, and we've got a vertical force at point D. So therefore, we've got all our forces. What do we need to do to get the unknowns? So we've got an unknown of HA, VA, VD. Therefore, we need to use our three equations, which is a sum of forces going upwards equals to 0, sum of forces as positive going upwards, positive to the right equals 0, and our sum of our moments about any point going positive is equal to 0. So that's our three equations. And again, hopefully, using those three equations, we should be able to solve the three unknowns. Let's start by resolving the forces upwards. So the sum of forces going upwards must equal 0. We've got VA, VD, which are positives. So we've got VA plus VD is equal to 0. Two unknowns in one equation, we can't really do much. So therefore, let's just say VA is equal to minus VD. And hopefully, we'll be able to use that a little bit later. Now let's look at the sum of the forces going to the right. We know we've got HA at point A and we've got Q acting at point B. There's nothing else acting at any other point. Therefore we can say a positive HA, as it's going to the right, and a positive Q is equal to 0. Therefore HA must equal to a negative Q. Great. Now we can take moments. Again, we can take moments about any point, but as I like to do, take a moment about the point where it has the most forces, as the perpendicular distance will be 0, and therefore the moment will be 0 at that point. And that's going to be point A, because we've got HA and VA, two forces acting at a single point, and therefore those two will be 0. That allows me to then concentrate on Q at point B and VD at point D. So looking at this diagram, we've got Q acting at point B with the perpendicular distance of being x. And now same with point D, as it's a vertical reaction here, the perpendicular distance is this length, which is distance y. So therefore we can say that the summation of moments at A is equal to Q, which is going to the right, going down, and going around, which is a clockwise moment, which is positive. So that's Q multiplied by X. VD, which is going up, to the left, and back down, which is counterclockwise. So that must be negative. And that's VD multiplied by distance Y is equal to 0. Therefore, we need to isolate VD, aka make it the subject of the equation. Therefore, we can say that VD is equal to, so we minus QX on the other side, we divide it by Y. As we've got minus on both sides, then we can cancel that through, which is QX over Y. And then what we can do now is substitute it into this equation. So we got, therefore, VA is the negative, or VD, which is negative QX over Y. So I hope that helps, and if you have any other questions, or if you did not quite understand that, please feel free to leave it in the comments down below. Please do like and subscribe this video, and if there's any other videos you would like to see, again, please list it in the comments below, and I'm sure to read it and help you guys.